When working with UVC, there are different possibilities. UVC is dangerous because it affects anything it hits, including people, viruses, bacteria, and the like. But if we want to use it, we also need to be able to shield it. And that's actually relatively easy with UVC. Since UVC is short wavelength light, it takes almost nothing to stop it. And I will demonstrate that now. For this purpose, I have my UVC meter here, which is a radiometer connected to a probe that measures UV from 220 to 280 nanometers. And it's important to know your measuring equipment when working with UVC. The probe must be approved and calibrated for the range you want to measure, and the radiometer itself must be designed for that purpose. And that's the kind of setup we have here. That means when I turn on the lamp now, my probe measures the UV from the lamp, and I get a value in watts per square meter on the radiometer's display. Then I can see how the different things work, which I will demonstrate now. First, I turn on my lamp, then I wait a moment. Then I start to get a number, a value for how many watts per square meter this lamp produces. And for the first 2 or 3 minutes with the type of lamp I've chosen here, the value actually keeps increasing until the ballast has regulated the lamp to the correct temperature. However, that doesn't stop me from, for example, now we have values that are relatively high. Here I have a standard piece of plexiglass just bought in the store, 3 millimeters thick. If I place it in front of the probe and hold it there for a moment, and the radiometer registers it, then you can see that almost all UVC penetration has disappeared. We can't get a value above 60 to 0.23. That means if I want to block this UVC effectively, I either need a different type of PVC or maybe 0.5 millimeter thicker. When building machines, it's often the case that people want to see what's happening inside the unit. And that's why we use glass as a shield so people can see what's going on inside. But the glass blocks the UVC. This means that when I take my glass here and hold it in front of the probe, and it just manages to register it, we have virtually no UVC passing through the glass. It actually drops to 0.000 when I hold the glass in front. And this shows just how effective and quick it is to shield against UVC by using ordinary glass or plexiglass. Since it's energy that comes out of UVC, it can be a bit problematic to use plexiglass. If I use this plexiglass sheet, it would become completely cracked and white within 14 days to 3 weeks, because it's energy we're delivering and the polymers will react to it. That's why we often use glass. But it also means that if I have a UVC lamp running in here, and you standing on the other side of a regular window, double glazing or triple layer 3 millimeter glass, it will block the UVC extremely effectively. That's also why I can stand here in front of my lamp with a visor made of 1.5 millimeter plexiglass, which effectively blocks the UVC. Since this is plexiglass designed specifically for protection, it's that easy to protect yourself from UVC and keep it contained in the areas where you want it to be used. However, it also has the drawback that if I want to build something, I can't use PVC glass to place things on, because the PVC will completely block the UVC from passing through. So if I had an object I wanted to treat and wanted to be able to place it on top, I can't use plexiglass since it blocks the UVC. I can't use regular glass as it blocks the UVC. That's why the glass our lamp is enclosed in is made of quartz glass. Quartz glass is the only type of glass that allows UVC to pass through. There is no plexiglass, polymer, or similar material that allows UVC to pass through. They simply haven't been invented yet.